Okay, this video is going to be the first one for our new unit. We are going to be working on relationships between lines and angles. So we're going to start with identifying parallel, perpendicular, and skew lines, as well as identifying the angles formed by two lines and a transversal. So a bunch of new vocab words that we will work on throughout this. And you will have a vocab sheet that you can add these onto as well. So if we look at the types of lines, a lot of this should be review. We all know what parallel lines are. Parallel lines, the new part we're going to add to that is they're coplanar, meaning they have to be on the same plane, and they do not intersect. So if we look in this picture, if you see AB and EF, they're both on this top plane, and they do not intersect. So there's some new symbols for that. Two lines going up and down is the symbol for is parallel to. So if we're talking about lines, remember we have a line on top with two arrows. In a picture, you'll also see that we're trying to show these lines parallel in the picture, so we use these little carrots or little arrows. If we have more than one set, just like with our congruent lines, we also use more than one arrow. So here's a set of parallel lines, here's another set. When they are parallel, we'll put the dashes on. We also have perpendicular lines. You guys know those. An upside down T represents perpendicular. Perpendicular means they intersect at 90-degree angles. So in this picture you can see that AB is perpendicular to AE because those two lines intersect at A and they create a 90-degree angle. A new one for us is our skew lines. Skew lines are not coplanar, so they cannot be contained in the same plane. So they're not parallel and they don't intersect. So parallel lines are lines that don't intersect, but they're on the same plane. So they kind of look like they're going the same directions. Skew lines would be more like AB and EG. Notice they'll never touch, but they're not on the same plane. So if here's EG going up and down, AB goes left to right, but it's further back, so they'll never cross. We'll look at some more real-life examples of that when we come into class, because it's hard to see on a flat picture. We also have parallel planes. So planes that do not intersect would be like this top plane and the bottom plane will never touch. In a real example, we have like the floor and the ceiling. Realize the floor and the ceiling are planes, but they'll never touch each other, so we say that those planes are parallel. Another thing to remember, we are talking about lines with these properties, but we can also say the same things about segments and rays. If we extend those, just like the rules, they can be parallel, perpendicular, or skew if the lines that contain them are parallel, perpendicular, or skew. Okay, so let's do a couple examples together. If we look in this picture and we wanted to identify a pair of parallel segments, well, there are lots of them. So let's see if we can choose ones that have markings on them. So if you look in this picture, if we look for some of the arrows, I see quite a few sets of them, but just right on top here, I see that segment LM is parallel to KM. It's also parallel to QR and PS. Notice that all four of those lines have arrows on them. So they're all parallel. If they just want us to name a pair, we can just pick two. So we'll say segment LM is parallel to, remember our symbol, QR. I could have said a number of them. So now if we want to look for a pair of skew segments, there's also lots of these. We want to pick one that's going left to right kind of, and one that's going up and down as well. So if I picked KN to start with, I could pick MR, I could pick LQ, I could pick PQ, SR. All of those are skewed to KN, so we can just pick one. There are numerous answers for these. So I could say that segment, remember a bar on top means segment, KN in segment PQ are skew. Now if we look for perpendiculars, this time we're looking for angles that, or segments that make 90-degree angles. So I see NS right here and SP over here. Since these are all making 90-degree angles, we can choose any two segments that create a corner. So I could say that NS is perpendicular to SP, remember our symbol, is an upside down T for parallel. Okay, now we're going to look for parallel planes. Well, since this is in a sense of cards, we can see that like the top card would be parallel to if there was a bottom card, a right card and a left card, a front card, and a back card. So there are numerous. How about we pick NMR, this front card, the three of, what is that, spades, and the back card, LPQ. Notice that these cards have 4 corners named with 4 letters, but when we name a plane, we remember that we only use 3, so I can just pick any 3 of those. So let's try one more set of examples. I'll go a little quicker, but if you want to pause this and try it, and then go back and check your answers, you could do that. So a pair of parallel segments, remember there are lots, but I could choose just the easy front ones. BF is parallel to EJ. I see that they have markings that are saying that same thing. So segment, parallel to segment. We remember our symbols. Okay, if I want to stick here with BF, now I'll pick a different segment that is now skew. So if this is over here, I see that ED is not on the same plane, and it's never going to touch it. So I could say BF and DE. BF, if I look for something that's perpendicular, I want to see something that makes a right angle. I see that little symbol right there. So I can say BF is perpendicular to FJ. Now I'm looking for parallel planes. I want planes that aren't going to touch. We can use the floor and use any 3 of those letters. So we can use FJH as our floor, and our ceiling, BCD. Those are parallel. So we can also use parallel symbols when we talk about planes. Okay, now we're going to look at some angle pairs that are created when we have what's called a transversal. So first of all, we need to know what a transversal is. This one's important. Any line that intersects 2 other lines at different points. Now they say coplanar lines. Most of the time they will be coplanar, but they got to all be on the same plane. Any line that intersects 2 other lines. So when we have a transversal, we have a bunch of different relationships. First of all, we have some areas that are created. When we have 2 lines, notice we have some space in between the 2 lines. We're going to call that our interior. We also have some space outside the 2 lines. Those are our exteriors. So that's going to help us make our pairs. And now we're going to talk about these angles in relationship to the transversal. So this intersection is always going to have a pair that relates to another angle in this intersection. So the first one we have are corresponding. Well, corresponding kind of means matching. So corresponding angles are angles that are in matching positions. Another way to say that is they lie on the same side of the transversal and the same side of the 2 lines. So the example we have here is angle 1 and angle 5. If I say same positions, notice angle 1 is the top left. So if I go to the next intersection, the top left is angle 5. So I could pick other examples. Angle 2, the top right, corresponds with angle 6, top right. As well, 3 and 7, bottom left, and 4 and 8, bottom right. So corresponding means matching positions. We also have alternate interior. So the alternate refers to the transversal. They're on different sides of the transversal. Interior means they're both interior angles. So we can't use 7 and 8 or 1 and 2 because those are exterior angles. So if I chose an interior angle up here, say I chose 3, on the other intersection, I want to have an interior, but I want it to be on the other side of the transversal. So 3 and 6 are alternate interiors, and 4 and 5 are also alternate interiors. Okay, we have alternate exteriors, same idea, but we want to use our exterior angles. So I could say 7, the one on the alternate side of the transversal, outside the 2 lines, is angle 2, and then angles 1 and 8. Our last one, our same side interior angles, also called consecutive interior angles, lie on the same side of the transversal, both interior. So 4 and 6 are a set of same side interiors, and 3 and 5 are a set of same side interiors. Okay, let's look at a couple examples. There are numerous sets, but if we want to give an example of corresponding, we're trying to find angles with matching positions. So if I chose angle 1, I'd see that that's in the top left. So its corresponding angle would also be in the top left of the other intersection, 1, 5. Okay, alternate interior. We could say, if I pick an interior, say I stuck with 5, my alternate other intersection would be 3. 5 and 3. You could also say 4 and 6. Alternate exterior, we want them both on the outside but on different sides of the transversal. So we could say 1 and 7. You could say 2 and 8. And then same side interiors, on the same side, both on the inside, 4 and 5, or 3 and 6. Good. One more example that you could try. What if it looks like this? So correspondings, we could say 1 and 3. We could also say 2 and 4, 5 and 7, or 6 and 8. Okay, alternate interiors. I want to be on alternate sides, but both inside, so I could say 2 and 7, or 6 and 3. Alternate exteriors, I could say 1 and 8, or 5 and 4. And then same side interiors, 2 and 3, or 6 and 7. I think one of the hardest things for us to do when we have lots of lines is to pick which line is the transversal. So to help us determine the transversal for a set of angles, locate the line that connects the two angles' vertices. So let's try a couple examples talking about that. If I want to identify the transversal of 1 and 3, so I see that angle 1 has this vertex, angle 3 has this vertex, so my transversal will be what connects those. So I'm going to say that line L is the transversal, and then it says identify the angle pair. Well, if this is the transversal, I see that they're both on the same side, so it's not one of the alternates, but they're not both interior. So I see that 1 is the bottom left, and 3 is the bottom left. So those would be corresponding angles. Okay, now we try 2 and 6. Well, here's 2's vertex, here's 6's vertex, so their transversal should be line N, and 2 and 6 are both inside our two lines, and they are on alternate sides. So those are going to be alternate interior angles. The next one, 4 and 8, I see that their vertex for 4 and 6 are both on line M. So their transversal will be line M, and they are both exterior and on alternate sides. So those are alternate exterior angles. Very good. Okay, one last example says to identify the transversal and classify the angle pair, angle 2 and angle 5 in the diagram. So take a second, see if you can figure that one out. So if we look at the vertexes, angle 2's vertex is here, and angle 5's vertex is here. So we want to say that N is the transversal. So if this is the transversal, here's our two lines. 2 and 5 are both on the inside of those two lines, and they are on the same side. So they are same side interior angles. Okay, hopefully this wasn't too bad. We are going to practice some of this in class, and I will see you very shortly.